Alright, hello, my name is Ethan Edwards, and today I'm going to be going over the Capstone project. Let me go ahead and talk about uh, some of my thoughts as I was coding. I was just I had to go back and review quite a bit of things, just trying to refresh things like RMSE, just different types when decision trees. So I definitely had to keep that in mind when doing this. That was just kind of my main thing with my thought process. Um, so without a further ado, let's go ahead and look at this code. So we're comparing two data sets and looking at models to see which one has a better prediction accuracy. So let's go ahead and let's run this code. These are the libraries that we need. Read Excel. This one's for evaluating models, and then this one is for decision trees, for creating decision trees. This reads in the data sets, the Excel files that we need. So let's go ahead and do a linear regression for body fat. And LM just means a linear model. We're predicting body fat percentage. Body fat. Let's predict the values, and as you can see, it comes up with different values to predict. And then RMSE, essentially it checks and see how close the predicted values is to the actual values, and we want a lower one to see how close it is. Lower one shows a closer prediction. See, all right, and the prediction is 1.23 with different ones after that. And now we're going to look at a decision tree, and we use this method ANOVA and RPART as we did earlier. The library is used for decision trees. Method ANOVA because this body fat, it is a numeric, and that is what we use for this RPART. And same thing with vector because it's numeric. And then we do the same thing with the RMSE. So let's see what it comes down to. All right, and it looks like in this case, it looks like the RMSE1 is actually more better at prediction for this case. And that's the linear regression for body fat. So it looks like it has a better prediction. It's closer. It's more accurate. So let's look at the lone result. So we had to do some kind of maneuvering with this one. So this is basically saying, because it's a classification, it's basically a binary classification. So kind of like true or false, 0 and 1. In this case, it's approved or denied. So we kind of had to use this if else statement to. So if it's approved, that means it's 1, else 0. So let's go ahead and do that. And for GLM is for the logistic regression. So essentially, and I have my numbers mixed up. I have the lone one down here. And then family binomial, it means binary. It's for binary classifications. We get a warning, but that's okay. Response, kind of the same thing as the binary. Let's go ahead. And for our predictions, we're using a confusion matrix. In this case, it's prediction accuracy, and we actually want it to be high. Print that out. See, we get something there. And we see our prediction is 0.2610294. What I'm going to do, because I was having a little bit of trouble, it was kind of combining. I'm going to run these separate, so I'm going to go ahead and clear my console and do it like that, and then rerun all my libraries. All right, and then I'm going to run this one down here. So the decision tree, we have to change it to a factor because, again, it's a classification, approved or denied. So we have to change that for the decision tree. And we have to change the method to class for classification. and we actually get an error. Okay, so there's something with this data set. It must be kind of messing some things up with running those two things, because I can run one just fine, but I can't run two, it seems. Huh. Maybe maybe do. Okay, so I'm just going to go ahead, and because I was having that issue earlier, and I apologize, but something is wrong, and I apologize for that. Thank you very much, and